Good afternoon, everybody, and a warm welcome to this AHDB Potatoes webinar. It's really fantastic to have so many of you join us. My name is Laura Bouvet. I'm Knowledge and Innovation Facilitator at AHDB, and I look after our knowledge exchange activities in potato storage. So for those of you that have been joining our webinars over the past year, it's lovely to see you back. And for those of you joining us for the first time, then a really warm welcome as well. And we hope that you find today's event informative. So moving on to a bit of housekeeping before we get into the topic of things. So for the purposes of this webinar, you're all on mute and your cameras are off. But you will be able to be sending questions through via the questions box that you should see on the right-hand side of your screen. Now, if you also have any technical issues, the question box is also the place where you can send any queries, and one of my colleagues will be able to help you out. The webinar is due to finish at 4:45. Depending on how we get on with questions, we might finish a bit earlier, but we'll make sure to finish by 4:45. Bases and Narosa points are available, so thank you very much for those of you who have submitted their details on the registration form. But if you haven't submitted anything yet, that's not a problem either. You can use the question box as well to send us your numbers, and we'll be able to get that processed for you. And just a reminder as well that this webinar will be recorded, so if there's anything that you'd like to go back on or review after the webinar, it will be available on AHDB's Potatoes YouTube channel, and you should also be receiving a link directly through to your inbox within 48 hours of the event. So just to give a brief overview then of today's programme. So we're now well into the storage season, and several of you will have, already applied mint oil or ethylene. And this season we've been hearing about, some of the challenges that growers have had when dealing with those sprout suppressants. And while some of you will be quite familiar with these, for others I think it's still quite new. But regardless that whichever stage you're at with using those sprout suppressants, I think as a whole, as an industry, we're all on a learning curve, and we're here to support you through that. So in today's webinar, we'll have Adrian Cunnington and Adrian Bridgen, both from Sutton Bridge Crop Storage Research, giving us a bit more insight into the latest storage trials that have been running at Sutton Bridge. Then we'll also have Graham Skinner from Provenance Potatoes. He's got some really interesting observations from stores that he's visited, specifically from the fresh sector. So he'll be sharing some of these observations with us. And then we'll also have Colin Davey from Spearhead Potatoes in a discussion with Adrian Cunnington. So that's actually a pre-recorded video from earlier this week, discussing practical solutions around store management. And then we'll move into the Q&A session. So please, throughout the event, keep feeding in your questions, and we'll be able to tackle them as part of the Q&A. Okay, well, if we can get started, Adrian, with Adrian Cunnington, who will be sharing with us some best practice for sprout suppression in storage. Adrian, over to you.
Thank you very much, Laura. Good afternoon, everybody. If I could have the next slide, please. I'm going to start with a summary of sprout suppressant availability. I think most of you will be aware of the content of this, certainly in relation to the 2021 column, but what's probably of more interest to you is what's going to happen in 21-22. At the moment, there's no certainty beyond the current choices, we obviously have an emergency authorization for a small amount of DMN use under a very closely controlled emergency approval running at the moment. But I'm afraid at the moment it's too early to say whether that option will be available for next season or whether we will get the full approval, which would be the ideal, I guess. We've also have no news on limonene either at this moment, and further down the track there's the potential for 3-dec and 2-own. But that's the current situation. We're really working above the blue line at the moment. There is a lot of work going on in the background to try and progress some of these other actives and their availability, and that will continue. AHDB is very involved with that alongside a lot of other stakeholders. So we'll report progress on that as soon as we have it. Okay, if I go to the next slide, please. So I'm going to just quickly go through one or two of the options for fresh. And the first thing I would say with fresh is, are you able to use no chemical? Because in many situations, at the temperatures we're storing for fresh market, it ought to be possible to use very little chemical at all, really, and in terms of sprout suppression. If you aren't able to go down the no chemical route, then why not? That may, for very valid reasons, be due to your market preference for certain varieties, maybe ones which have got very short dormancy. You may be looking at extended loading periods for configuration of stores that you've got. You may have chosen to store at a slightly warmer temperature so that for mitigation of acrylamide. And probably more widely, you may be using chemical because your storage temperature has got quite a lot of flex in it. In other words, you might be storing at a target of 2.5, but it might be plus or minus 1 degree, might be plus or minus 1.5 degrees due to problems with airflow, levels of insulation, etc. And those particular stores are ones which we could target to see if we can improve the situation and try and get you into a situation where you use less chemical. But for many longer term stores, it may be necessary to accept that treatment has to be used. So we'll just move on to the next slide and start looking at some of those options. So spearmint oil, the approval holder here is a company called Zida in France, and the marketing in the UK is done by a company called Juno Plant Protection, and there have been some evolution of the label for spearmint oil. So it's important to speak to your contractor to make sure that you've got the latest information in the use of this chemical. Next slide, please. Okay, so one of the really crucial things that we need to ensure when we're using mint oil is that the crop is dry. And to achieve that, we recommend that you run fans without cooling for 24 hours prior to application, just to ensure that there is no condensation anywhere within the stack or within the boxes. Work with your contractor to set up the store correctly, getting the chemical introduced in the best possible way to give it a free flow. And it's really important to use reduced speed fans to recirculate the mint oil. And there's a lot of discussion about fan speeds at the moment. My advice would be to strike a balance between moving enough air and fog and risking localized concentrated deposits of the chemical. So if you've got small fans, you're at more risk of some localized concentrated deposits, and I know that Graham's going to flag some of that up later, so we'll move on to the next slide, please. The other option that we have is ethylene through restrain generators or use of safe store cylinders. It's widely used in the fresh market, has been for some time now, but it doesn't have a great deal of residual action. It is really essential that we ramp it, and it is now being used in processing, especially for McCain, who are using it as a single treatment across their varieties. The one point I would caution right now is the use of it in chip shop supplies, particularly if you're in varieties, working with varieties that are not fully tested. I'm just nervous about ethylene being used with varieties that we don't understand fully, and I'll come back to some trials we've been running on that as well. I know Adrian Britton's going to talk about rates, so I'll move on from that. The important thing with these new suppressants is that we need to change our practices. We're definitely not dealing with a plug and play situation using the new products in place of CIPC. We're having to look in the trials program that AHDB is funding with combinations of sprout suppressant products, and we're also looking at interactions with a lot of other aspects of store management, management of closure periods and consequences of that, choice of temperatures and varieties. All of these things need to be looked at closely. Next slide, please. So attention to detail is really important from the sort of store side, from the engineering side. Sealing stores well and preventing any form of contamination with adjacent stores is very important. We don't want products like ethylene leaking out into other stores where they might not be as suited. We need to look at our flushing methodologies and control, and again Adrian will talk about that. And I think we're going to see an increased use of refrigeration working with these current chemicals compared with ambient, just because we need to keep the chemical in the store and use less ambient air. When we use ambient air, then that chemical is going out of the store, and at the price the chemicals are being charged out at, then that's not particularly affordable or sustainable. So that's something that we need to look at further, and I'll come back to that in a moment. Next slide, please. Okay, so very quick overview of the combination treatments. And really the point to make here is that this is in processing. This is the mean of all the cultivars from last year's work at 30 weeks storage. And the one thing that really strikes us here is the impact of maleic hydrazide and the combination effect of maleic hydrazide with the actives giving a significant improvement in sprout control over the MH3. So I think that is an important aspect that we need to understand better. If we go to the next slide, please. We can see the same effect here in our fresh trials. We've got, in this instance, the MH3 on the left and the MH treated on the right in orange. And all of these bars are showing significant impact of the maleic hydrazide treatment in providing an element of residual control, and this is really brought to the fore in the shelf life trials which follow this this work. And if we go to the next slide, this is 12 days of shelf life at 12 after the varieties have come out of store from 4.5, and we can see here that even though we're not adding any additional chemical, that residual component from the maleic hydrazide is coming into action and providing us with a level of control across shelf life which isn't being afforded by the MH3 treatments. So I think it is important that we consider the impact of maleic hydrazide and the value of maleic hydrazide in providing that residual control that we haven't had since the loss of CIPC. Next slide, please. So these next 3 slides are just going to be very simple slides, really, and I don't want you to read any of the text particularly. I just want to illustrate that we are testing varieties for their sensitivity to ethylene and their suitability for storage in ethylene, and also we're testing them for suitability for storage at cooler temperatures, 6 degrees. These are all processing varieties, and the ones in yellow have performed well both in ethylene and under cooler storage. The ones in green just in ethylene alone, and the ones in blue just in the cooler storage. But this is 1 year's work from a single trial where we had about 50 varieties in the trial, and there are certainly some anomalies in this data, and there are also some variations between multiple replicates of the same variety. So at this stage, by all means, go onto the Storage Hub and have a look at the report, but do treat this data with caution. I think we need to get at least another year's data under our belt before we make too many recommendations. These are the chipping varieties. So you can see here that there's several varieties have performed well. The 1s and 2s are the 2 different sampling occasions. So if they're in the right-hand column, they gave the best quality at that particular sampling occasion, and in each case. So ethylene in the first 2 columns, cooler storage in the second 2 columns. So that's how that particular table works. Next slide, please, will show us the crisping varieties, and here we've got the controls on the right, but again, the same format, and again, fewer varieties that are performing well. And if I just take the opal at the bottom, you can see there that there's one particular stock of opal that gave us some good results, but the other 2 from opal didn't. So there are other factors in here, probably site interactions, and so interpretation of this data is going to be quite difficult, and we will need to look at it in a lot more detail than we've been able to so far from just 1 season's trials. And the next slide, please. And this is the other crisping varieties, and again, certain varieties standing out as like Verdi that seems to respond well, but other varieties like Taurus, which don't seem to respond very well to ethylene or cooler storage. Next slide, please. So just going on to costs, just wanted to put a little bit of information up about scenarios for costs, particularly in long-term storage. We can ignore line 1 because that's CIPC, but it does show us a reference point. If we've just gone down the plug and play route at the moment with keeping more or less the same temperatures, using maleic hydride, but with several doses of mint, then we're going to be racking up quite a significant cost, which I would say is a high risk strategy from a sustainability point of view. If we're in a situation where we can use ethylene, then the costs will be more manageable. If we have ethylene sensitive varieties, if they're not ethylene sensitive, then that could be very damaging, and that's why I expressed caution about chip shop varieties. And in the longer term, I think we need to be moving to more new cold tolerant varieties or new long dormancy varieties, or both, because there's potential there to lower costs significantly, and I'll come back to that point in a second. If we can look at the fresh market next. Again here, top line shows us we were probably spending around about £8 or £9 with CIPC and fridge. We're currently, if we're using fridge with mint and maleic hydride, then we're probably getting up to sort of 13 or 14 pounds a ton. And with ethylene, we might be in the sort of 10 or 12 pounds a ton by the time we've taken the fridge into account. If we can get down to that no chemical regime I was talking about earlier, then maybe we can lower that down to about £10. But again, in the longer term, we really need newer, longer dormant varieties where we could probably store at 4 or 5 without the need for chemical, or wait maybe with just a single treatment of something like MH or DMN, and we could get down to about £7 a ton. So those are the sort of things we need to be looking at in terms of our longer term planning and direction of travel for storage. Next slide, please. And this just summarizes that whole point really, that This is integrated potato store management. At the top of this triangle, we've got chemical use, which is something we've relied on heavily in the past. We've got management and intervention in the blue band, which will continue to be necessary, but we need to get smarter at it. And we can do that by looking at issues such as risk in the yellow band, so getting better measures of risk and being cleverer in the way that we predict our store qualities, so that we're only storing the varieties and the crops which are going to give us the best returns. And right at the bottom is having a really good genetic base for that whole storage regime, and that means things like variety choice and dormancy needs to come to the fore in the next few years if we're going to improve our storage and make it sustainable. Next slide, please. Finally, just to finish, I just wanted to mention the AHDB storage network. We're coming back after the lockdown restrictions at last. If we've got any issues in potato storage, then now is a good time to be getting a handle on them, and specialist help on your own site from an AHDB storage network partner will be available from, we think, the 12th of April. It's a free service, so do call that number on the screen if you want to take advantage of that, and I will finish there. Thank you.
Thank you very much, Adrian. That was a really insightful information into the latest storage trials, and good to hear that. Yeah, storage network is back on. So please, you know, do give us a call and book in your visit. We'll now move on to Adrian Bridden, who will be giving us some more insight into some other trials that have been going on at Sutton Bridge. Thank you, Adrian. Over to you.
Okay, thank you, Laura. Hope you can all hear me and see me. Right, okay, I'm not going to talk about sprout control, just for a change. So we've done a lot of talking about the different products, and I hope we can all rank them now. But I'm actually going to start talking about some of those other issues. Can I have the next slide, please? Okay, so ethylene and spearmint oil are now in widespread use. So it's the first year without, for many of us, the first year without CIPC. And many of you have used MH, and by all accounts, those applications have been effective. Now, everyone I've spoken to has given the weather the credit for that. Maybe we should give some to the growers and the agronomists too. Right, so we've now got a lot of ethylene, or a lot more ethylene and spearmint oil being used. So they're both previously used mainly in the packing sector. That's where they were established, and now all of a sudden we have a lot of use in the other sectors, especially in processing, and that's given rise to some significant changes in practice. So if you didn't apply in the processing sector, if you didn't apply MH and you are depending on spearmint oil, you will probably have noticed that applications are more frequent. So reapplications are necessary relatively early. Can I have the next slide, please? Right, but with that comes one of those changes that we knew was going to happen, and this regards the store closure period. Right, so if we carry out an application of a post-harvest chemical, the first thing we do after the application is shut the store up and stop active ambient air exchange. So we prevent people going in, and we ideally will prevent, as far as possible, any of the active coming out. Right. When we had CIPC, that was very straightforward. So this was carried out 6 to 8 hours after the application was complete. So the fog settled quickly. CIPC was a solid, so it settled out very quickly, and we could then flush the store, and we didn't lose CIPC in that process. Right, with the newer products, or with BIOX-M at the moment, that is very, very different, right? So the BIOX-M label tells us that we must keep the store sealed for not less than 48 hours. And in some of their technical documents, they say if the store is only part filled, for example, you should leave the store sealed for even longer. Right, so that if we move on to the next slide, please. So that gives us a special set of problems, and that is carbon dioxide. So carbon dioxide is generated by the potatoes themselves, and when we ventilate the store or flush the store, what we're doing is excluding or expelling the carbon dioxide. Right, so with BIOX-M, if we're leaving that store sealed for a relatively long period, that's a period without active ventilation, and therefore a period over which CO2 will accumulate in the store. So last season we did this piece of work. So this is so we had a conventional BIOX-M store, and in that conventional store we held we set the store control system to not allow a carbon dioxide concentration in the store headspace above 0.3%, and that's roughly where people would set it at the moment. Right, we compared that with another store that had exactly the same timings of BIOX-M, but the store control system was set not to exceed 1% carbon dioxide in the store headspace, and you can see that the system has done what it should have done, and we have some very big differences in carbon dioxide concentration. If you move on to the next slide, please. Right, so that's when the store is under control, and then obviously every now and then we come in and we want to apply our chemical, BIOX-M in this instance. Right, and then actually the store is switched off, or ambient ventilation is switched off, and what we get is CO2 accumulating to higher concentrations. Right, so here you can see in the control store, which is the middle column, so that store was left sealed for 48 hours, and you can see after the first application we achieved a little over 10,000 parts per million, so that's 1% carbon dioxide. And that the final application in May, 14th of May, the application resulted in 1.6% CO2. Right, if you compare that with the next column, so this is the store that we allowed to achieve 1% carbon dioxide, right? That was in combination with a store closure period of 3 days, so 72 hours. And in that instance, so the application was done at the same time as in the control store, but it was sealed for another day for an extra 24 hours, so it's appearing on the next line. But that is having quite a dramatic effect, and we see very high concentrations of carbon dioxide if we leave the store sealed for 3 days. So that's 2.75%. At that last application, and we did this also with another post-harvest treatment, and there is a trend towards higher carbon dioxide levels accumulating as the storage season progresses. Right, and so these kinds of carbon dioxide levels, right, they should make store managers nervous. They should make all of us nervous, because there is a human health implication here, so we do need to be careful. But if we go on to the next slide, what we see actually is that the potatoes don't mind so much. So here we've got 3 plots. So this is after 35 weeks of storage at 9 degrees. So for the left-hand plot, this is Maris Piper. We've got the BIOX-M, so the left 2 bars in that first plot. The left 2 bars are for BIOX-M in the control store. So these were sealed for 48 hours. and between applications, the store was controlled to 0.3%. And we compared those with the left two bars, where the store was controlling at 1%, and the store at application was sealed for 3 days. Right, and actually what we see is no effect on fry color. Right, so that is interesting, but it isn't. It's not as revolutionary as you might think. So if we go on to the next slide, please. Right, the reason why this is, right, so this was work done about 10 or 12 years ago. Right, there has always been a lot of interest in carbon dioxide and potatoes, and that's because the literature was never very straightforward. So if you read all the literature, half of it says, you know, half of us, if you read all the literature, half of us would control CO2 and the other half wouldn't. Right, and I think what is going on is shown in this plot. Right, so if we look at this, right, what we have here, right, that top line is in the absence of ethylene, what that is showing us is that increasing the carbon dioxide concentration is not changing the fry color. So effectively, statistically, that top line is a flat line, it's horizontal. But the other two lines, they both have slope. And what the difference between those two lines is ethylene concentration. So what they are showing is that if there is ethylene around, then there is a dose response to carbon dioxide. So exposing crops to carbon dioxide, if they have a sniff of ethylene, is damaging. Right, so if we go on to the next slide, right, so this is my conclusion at the moment. We're going to do we hope to do a bit more work on this. So this work has sort of confirmed, so carbon dioxide is not important in determining fry color as long as ethylene is absent. And what that means is that we must not use conventional foggers, we must use electric foggers, or we must use heat exchange foggers where extended closure periods are being used, such as for BIOX-M. Right, and don't forget, it's worth noting, right, the current BIOX-M label, so that's map number 16021, warns us on the product label about hydrocarbon propellant. So if you're burning petrol or gas or diesel to generate the fog and introduce the fog into the store, then you are risking an effect on fry color. Right, and then the final point there is carbon dioxide and ethylene. Right, I'm not suggesting that we should relax carbon dioxide management when we're using ethylene as a sprout suppressant. And then finally, so health and safety, don't forget there have been problems with this. Carbon dioxide, there is a operator exposure level for that. So it is damaging, it can be damaging also to human health. Okay, can I have the next slide, please? Okay, I'm not going to talk very much about ethylene dose rate. So all the work that we have done at Sutton Bridge in recent years has worked at the 10 part per million rate that was initially introduced by Restrain. So we continue to work at that rate, but we are conscious and people are asking us about other rates. So we are comfortable with other rates, but we are not we're not experienced in those rates. But certainly the literature is suggesting levels down to 4 ppm. So currently we're working at 10, but levels down to 4 ppm are not shouldn't cause any issues. Right, the other aspect of ethylene, if we move on to the next slide, please. The other aspect of ethylene is that gets talked about, widely known, and that is fry color. and you've heard Adrian Cunnington already mention fry color issues a moment ago. Right, so ethylene does, can't argue with it, ethylene does influence fry color. That effect can be slight or severe. Right, it seems always to be associated with the startup of ethylene, so that first introduction of ethylene, and is then followed by recovery. Right, what we find, or what I find, if we have the next slide, please, is that with careful management, what we actually have is pretty much a negligible effect on fry color. So these again, so the plots, so we've got 3 plots here: Piper, Performer, and Royal, comparing ethylene and BIOX-M. So I would use now BIOX-M as my industry standard. So for MH-free and MH-treated crops, all these crops produced fine, good quality fries. You will see that sometimes ethylene is darker, but the quality of the chips is still good. And sometimes ethylene is lighter. So there is no, as long as there is very careful management of that ethylene, and by that I mean that initial startup, and there is certainly a possibility that that could be managed to be even more gentle than it is currently. But as long as that is very gentle, fry color issues are more about risk than actual issues. We'll move on to the next slide, please. So we have seen effects on fry color, but they are not usual, and most potatoes at Sutton Bridge, when we store them under ethylene, are like the ones shown in this picture. So wider use to me seems appropriate, but I would still be a bit nervous about on the crisping side, where even very small changes in reducing sugars will have an impact on fry color. And I think at that point I can hand back to Laura.
Thank you very much, AB. That was yeah, really insightful information again as well. You know, looking at ethylene and you know, any effect on fry color. So it'd be actually quite interesting to hear from, you know, any of you in the audience, whether you've had any issues around fry color when using ethylene or mint oil as well. So if you've got any questions on Adrian Cunnington and Adrian Bridden's presentation, please do keep feeding your questions through, and then we can tackle them in the Q&A. But without further ado, I'd like to introduce you now to Graham Skinner, who will be focusing on the fresh sector a bit more and talk to us about some of the observations he's made this storage season. Over to you, Graham.
Thank you. Good afternoon. I've just put a selection of slides together. The first set looking at MH, the second on mint oil application. Like many, our use of MH in previous years was focused on a problematic variety like King Edward's, but its main use was in the chipping stores. We moved to using MH for all storage crop this past season, and decided to place samples of different fields, different varieties onto shelf life at harvest, and monitor what those shelf life, those tubers did without any further chemical treatments. So a lot of the pictures you're about to see, you're talking 5 months of shelf life on ambient. Can I have the first slide, please? We did have an opportunity in one field where we switched the boom section off. This variety is King Edward, so this is non-MH on the left versus the MH on the right. Dug side by side, and as you can see, the MH here in this crop worked particularly well, and on the left hand side you can see very dominant apical dominant chitting. Next slide, please. Looking at the shelf life samples, it's quite common. I would say virtually every sample shows variation in control. So this is just an example of one sample showing the variation we get from an MH treatment, which I'm sure is of no surprise. This variation, say, was very common across all the samples. Next slide, please. Also, what was apparent was size. Small tubers, these are only as, say, MH treated. They seem to also struggle in terms of getting enough MH into them. I assume that's what's going on here. And also disappointing in that that's what's most likely to be lost at harvest time. Next slide, please. One thing I hadn't picked up in previous years, mainly because virtually all crops were having CIPC treatments as well, was how tubers sprout purely under just MH. So we have two varieties here, Edwards on the left, Camel on the right. The Edward, as you see, looking at the apical chits, has been really trying to sprout. The Camel's far dormant. But in many of the samples, next slide, please, where the apical chitting had been stopped, other eyes opened up. So here on the left is King Edward at the stone on end, showing a very distorted sprout, and the Camel on the right. Next picture, please. And this is another variety, Desiri, showing apical control. But again, once the tuber can't sprout from that apical point, it seems to start going away from other eyes. Next slide, please. This tuber probably sums up what symptoms I'm seeing or observing in many of the samples, where the apical chit on the right-hand side has been controlled again, a very distorted chit in the middle of the tuber, and at the stolon end on the left, chits growing more away normally. So there's obviously a distribution of MH, I'm assuming, going on within the tubers here. Next slide, please. Again, this is just another variety showing the apical chit on the left being controlled, and then the sprouting towards the stolon end. So that's probably something I didn't expect to see, but I'd say that's probably because that was being masked in the past in store through CIP treatments. The rest of the variability you'd probably expect to see from MH. Next slide, please. Previous to this year, our mint oil applications were based on emergency treatments, so often a King Edward crop requiring its chits to be burnt off, and this worked very well with no deposit issues. This year was different. We've used it in a more proactive way, and the first two stalls we treated, we ran into some deposit issues. This store in the picture here, we had treated in previous years with mint oil, but because we were using CIPC, we actually constructed a plenum in the boxes with fans on inverters and mint oiled into the plenum. This year we decided not to use the plenum, and we mint oiled through the side entry gassing port. That side entry gassing port also had shorter rows between it and back to the fridge unit. This fridge unit has no inverters, so the fans were run flat out during application and continuously through the lockup period. But after inspection a few days later, it became apparent that we deposited onto the top boxes from the left-hand tower of the fridge unit, i.e. the side where the gassing port was. The right-hand side had no deposit. So I'm assuming the fog short-circuited down that side straight into the fridge unit. Next slide, please. Just an observation on the front of the coil. You don't realise how dirty they are till you take a picture. I don't know whether it's big enough to see, but the cobwebs on the front of that coil, you can see droplets of mint oil on. So a bit like spiders' webs in the autumn and the dew. The coil itself I could not see any deposit on, but the cobwebs were showing it. Next slide, please. In the same store, we decided to use the roof fans during application. These didn't splatter the mint oil. The fan blades seemed to deposit the mint oil inside the cylinder, and this was blown to the front of the fan, and this dripped down. Previously, we hadn't used roof fans, but we did in this case here, and again, a small deposit was occurred from it. Next slide, please. Moving on to another store. This was a new build store where 40 mil a ton rate was used at a reduced rate. This store had inverters, so these were run at 80%. I think it's about 60 CFM. We ran them at 80% during application and the close-up period. And we had a small deposit from the middle duct in two areas there, out at the front of the duct, and you can probably see the deposit of oil lying in the bottom of that duct. And to the rear of that box where there's a join in the actual duct where it dripped through. Next slide, please. But it was only that middle duct that deposited. The outside ducts in that configuration did not deposit and had no visible deposit in there of mint oil. This store here sees a rear plenum with inverter control. Subsequently, what I would say is we then treated two further stores at that site with a similar design or virtually identical design. And rather than running 80% during application and just after, we ran at 30% and then ramped up the speeds after the fog had turned into vapor and subsequently saw no deposits. On the older fridge units, we moved to where we have no inverters. We moved to pulsing during the application and just after. And again, we had no more further deposits. So those were the two stores that gave deposits this year, and I think very much down to, in many ways, the fan speeds we were running. Next slide, please. That's just showing a heavy deposit of mint oil, what the effect can be. That happens very quickly, but for those that haven't seen a mint oil deposit and how it can, for want of better words, burn, that was just an example of that. Next slide, please. I mentioned the 40 mil rate earlier. Normally would be going at 60 mil in cold store. But in this cold store here where we have MH on our side, it's a new build, well sealed, decided that we'll have a go at the lower rate because if we can't make it work here, we probably can't make it work in anywhere else. So this variety here, Laura, the pictures on the left-hand side were taken back, well, the dates are, as you can see there, approximately about 2 weeks after application. And at 40 mil, there wasn't a complete burning back of chit, but a reasonable effect. And as you can see, those tubers on the right-hand side of a picture taken last week, I'm comparing the worst sprouting there that we had present prior to the mint oil. The majority of tubers were more bright-eyed rather than that level of sprouting. I think it's too early yet to say has the 40 mil worked. Done two further stores and with contrasting varieties like Desiree and King Edward at 40 mil. All I can say so far so good, but there's an awful long way to go. And there are other aspects such as our King Edwards this year seem to behave ourselves better than they can do in other years, i.e. they were less sprouting at harvest time. Next slide, please. This goes back a full season. So this is the Desiree crop. It was treated with 12 grams of CIPC in September 2019. It was kept long term. It did not have any MH applied to it. And on probably reaching the rear third of the store and outloading, came across some sprouts. So it was decided to move to a small store with a rear plenum and also with inverter drives and treat with 60 mil, because past experience had been very good and you'd expect a lot of chit blackening from that and burning off. But in this case, we virtually achieved very little. We had the odd pinprick, the very growing point of the chit, with slightest blackening, but very minor indeed, across the whole 200, 250 tons that would actually moved in there into the store to treat. So it's very uniform lack of effect. I don't know why, but I suspect those chits we discovered had been there for a considerable period of time, and they weren't as fresh and young looking as they do in those pictures there. But that was a disappointing treatment compared to what we'd experienced in the past and subsequently. And that brings my presentation to the end. Thank you.
Thank you, Graham. Some really interesting observations there then. And we've had a number of questions come through, so we'll make sure to go back to those when we go into the Q&A. We'll now move on to the conversation between Colin Davey and Adrian Cunnington that was recorded previously this week. And then we'll go into the Q&A where I'll ask all the speakers to join us. But for now, we'll have the video play. Thank you.
Good afternoon, Colin. How well are you finding these alternatives to CIPC are working in your stores?
So we're predominantly using BIOX-M. I'm not using ethylene in any of my stores. We're seeing, I would think to be fair to say, acceptable levels of control in bulk stores with good ventilation. However, we are seeing more difficult control in some of the box stores. I think that'd be fair to say.
Okay, and would you put that down to poor distribution of the chemical or airflow patterns, that type of thing?
Yeah, there's something going on there. I think we're initially, I think we were led to believe that the chemical was more volatile than perhaps what it is, and would mix in the store a bit more, and would have a more even kill than maybe what we'd seen with CIPC, but I don't think that's the case, or it doesn't appear to be the case. So we've had to increase airflows to move the chemical around box stores a bit more. We were seeing pockets in box stores that weren't being touched from it. These higher airflows on the second application seem to have improved the efficacy and control, but it's not by any means perfect, so we've still got work there to do.
Yeah, I think there's a case for having to drive the air around the store to get it into the difficult areas, and inevitably cranking the airflow up is the only way you're going to achieve that, unfortunately. Yeah. But that's fine as long as it doesn't imbalance the distribution elsewhere in the store. But I think it is definitely a balancing act between having enough air and having too much air. Have you had any instances of fallout of the chemical anywhere?
No, nothing in store. I think that was it was a big concern going into the season, one of many, but yeah, I haven't seen any fallout of the chemical. I have seen on one of the earlier applications that I'd done on a very thin skin variety on its first application, a slight burn of BIOX-M where we had a bit of scuffing from walking over the crop. That's the only thing I've seen. Nothing else. Thankfully, no damage to any insulation or anything. So I'm happy with that. Okay,
and as far as the application regime is concerned, presumably is that being done by a contractor?
Yeah, so we're using, I think, most of the 3 or 4 main contractors in the country. So most of them now are using, if not all of them now are using their new fogging systems through a heat exchange, which does seem to have reduced the risk of any CO2 buildup. We've been monitoring CO2's levels in our stores quite rigorously just to see, and we're not seeing high levels. And on top of that, we're not seeing any deterioration in sugars or fry quality, which is good. That's then maybe allowed us to keep the stores closed a little bit longer to try and improve the efficacy of control. So that seems to be where we're going, which I think it does work. My concern is, where do we stop? Where, at one point, do we stop the close up and the sort of the post ventilation regime? I'm starting to get a little bit concerned on sort of clocking too many hours up in dehydration on some of this post application.
Yeah. Okay. So typically, what period are you leaving stores closed after application? And are you 48 hours, 72 hours, or
72 hours? I think is a rule. We seem to be getting better control with 72 hours than we did with early applications at 48 hours. And so we monitored the 48-hour application and low levels of CO2 build up, and say no negative effects on fry. So yeah, we've lengthened it, and yes, I can see better control at 72 hours. I have closed a couple of stores up for longer, and once again with no negative effects on fry, and slightly better control on scorching of the sprouts back.
Okay, that's good. And cost-wise, sort of dose rates, that type of combination, how are you managing that?
I think as a general, I'm doing mostly 60s.
Yeah.
I have done a couple of 90s where the result, it needed it, and we've seen better control at 90, but it's, 90 isn't good enough for long-term storage for us. We'll run out of chemical, so we can't, apart from the cost implication of it, it's not something that we can do as a general routine. So say 60 seems to be okay, and 60 is working well in bulk stores, but it's the box stores that it possibly feels that 60 is a little bit too low still for whatever reason.
And sort of coming back to the bulk stores, I think the really crucial thing there is that you've got the benefit of positive ventilation in bulk stores, so that's the be all and end all of getting good distribution, I think.
That's right. I totally agree. But we once again, we have gone up in the ventilation a little bit there. We tried different things in some of these box stores, partly out of necessity, but just to understand how it would go. So we've had different application points. So we've applied below the fans, we've applied into the loft space. We've been in a position where we've had to gas one side of a store with a shared air tunnel, and we've also had to gas part-filled stores, and they've all seemed to be okay. They all seem to be okay this season, so we don't seem to have any negative effects of that. So that's good.
That's good. You sort of stressed this season there. I mean, do you think the maleic hydrazide that you've been using is giving us an advantage this season?
Yeah, definitely, Adrian. We've got good uptake. We've done testing in sort of trying to preempt the possibility of using DMN this year, but we've had high levels across there, and I think that's across the board. To be honest, the colleagues in other companies have all expressed similar high levels, and I think we are seeing the benefits of good MH uptake this season. I think we will struggle, or I fear that we will struggle in another season where we haven't had as good uptake. So
yes, so I think that's important, that we keep looking at all the options, and obviously DMN is one of those options that we might see in the future. And have you any experience with DMN at all?
Yeah, so I've seen it pre-lockdown. I managed to get out to see a couple of stores in the continent sort of this time last year, and I have seen one of the stores that's been treated in the UK this season, and it looks encouraging. It really does. It looks from those early stages to be good. And I feel it would be a better chemical for us, and than what we're trying to deal with the BIOX-M at the moment.
Yeah, I think it's going to be a case of trying to get all the best tools into the toolbox, and that's just going to take a bit of time, unfortunately. And but hopefully we will get there in the end. So that's really useful, Colin. Thank you very much for that feedback. That's really helpful. Thank you for your time.
Okay, that's great. Thanks, Adrian.
Sorry, Laura, you're on mute currently, I think.
There we go, that's better, isn't it? Sorry about that. No, I was just saying thank you very much to Colin and Adrian, and I guess if I could ask all of our speakers to turn their cameras on and have their mic on, and we can have a bit of a discussion to build on what we've heard today. So I think something that I'd like to start with, and we've had several questions on this, is the issue around recirculation and air recirculation and fan speed, in particular with mint oil. So we've had a question come through. I think probably one for you, Adrian. Adrian Cunnington, do you recommend regular recirculation using store fans following mint oil application? And if so, what interval and length of fan run would you recommend, and for how long after application?
Okay, so definitely we would recommend use of fans, and I think we've heard in some of the presentations that there's quite a variety of different thoughts on that. I think we're generally looking at a slightly more aggressive airflow using mint oil than we would with, for example, CIPC. So slightly faster fan speed, more air volume. But I would just sort of qualify that by saying that I get a lot of discussions with people about whether they should be running fans at 50%, 60%, 70%, 80%, whatever it is. And I think we really do need to get back to some basics as to what the air volume is and the air speed is, because we can use percentages, but percentages are only related to the fan capability, and there's an awful lot of different fans out there as to being used in stores. So we need to think of more specifically about what air speeds we're using. Typically, I would say that we don't want air speeds more than about 5 meters a second or 1,000 feet a minute, because I think those types of air speeds become excessive if we're not careful. And in most potato stores, we ought to be able to move air around perfectly satisfactory at that sort of speed. And the volumes will depend on what we're doing. In terms of a collective, are we using 2 main fans? Are we using lots of small fans? But as a guide, I would have thought that collectively we ought to be moving something in the region of 0.02 cubic meters per second per ton. That's the sort of area we want to be in, which is the old-fashioned 40 CFM a ton. That sort of level of air moving around a store is going to give a reasonable distribution. But we do need more data on this, and any feedback we can get from if there's any of the contractors listening, if they're able to provide us with feedback, or any growers who know what they specifically they're using, if you're able to help us, then we'd really appreciate that, because I think we're all on a learning curve here, and it's interesting to hear what Graham said about fallout in some of the stores he's experienced, and then Colin on the contrary saying that he hasn't had fallout issues. So he must be doing something pretty well right there in terms of getting the air around the store satisfactorily. So, but everybody's situation is different. Graham's using colder temperatures than Colin, so fallout problems probably more of a risk. So we need to look at those that combination of factors. And if any individuals want to call us at Sutton Bridge and talk to us on the storage advice line about their specific circumstances, then they can contact us on the 0800 0282 111 number.
I've got the number up in one of my last slides, so we can go back to that, Adrian. But actually, it'd be really useful to hear from Graham and Colin. Hear a bit more about the fan speeds that you do use or you've been using, and any issues. Graham, you mentioned some of those in your in the presentation that you had, particularly to do with the coalescence. But perhaps if we could start with you, give us a bit more insight into fan speeds and recirculation rates, and then we'll go to Colin to hear from your experience.
Yeah, so in previous years we hadn't seen any fallout. It was only this year where we experienced it. So what we did, we did two options then on where we had inverters available. So that store with a small deposit. During the fogging process and shortly after, we ran slower speeds, so that would have been 60 CFM with a 30%, so I'll let Adrian work that out. Once the fog had turned into a vapor, which happens very quickly, we went back up to 80% and then did some alternation for the shut up period. So we may do 3 hours at 80, 2 hours at 40, and alternated it. Where we don't have that facility either because the store controller doesn't allow it or just the design, and we were stuck with just the fridge units, we moved to pulsing. And in a number of cases, we just either used the controller or even the manual defrost just to blow for 10 minutes, off for 20 minutes, blow for 10 minutes, off for 20 minutes. But once the risk period I see is when the fog is being applied and it's actually a dense fog. Once it's into a vapor form, I think the risks of the deposits are reduced greatly. So it's just the initial fan speeds to me that gave the greatest concern.
And is it through trial and error, I guess, that you came to those conclusions, to what worked best for your situation?
Yeah, I think it is, because what Adrian said there is all stores are different layouts. We talk in general terms like percentages or fast and slow, yet we don't really define what that means. But it came as a bit of surprise after not having deposits in previous years, but have the deposits at the beginning of this season, came as a bit of a surprise. Because we decided in a number of cases we were building plenums in cold stores for the use of CIPC. Those plenums are difficult, and safety-wise it's difficult to build them, take into account health and safety. So we did away with them, but I'm beginning to wonder whether there'd have been a benefit in terms of mint oil as well. So risk, really trial and error, and therefore it's very observational what you're looking at and hard to actually put true numbers to it.
Thanks, Graham. Adrian, did you want to comment on that at all?
No, I don't think so. I was going to ask Colin if he's got anything further to add on his experience, really.
Yeah, Colin, please, it'd be great to hear from your experience and how you found that.
Yeah, I think my experience was very, very similar to what Graham's quoted there, where we've got lots and lots of various different stores, and so we're not seeing that level of deposit that Graham's quoted, but we are trying different fan speeds. As in the recorded interview, it's primarily to try and push it about a bit more in the store. We were finding that we perhaps weren't getting it into the corners as much, and so hence we're going for a bit higher in the airspeed. I think slightly higher than the 40 CFM that Adrian's quoted there. And so we are using bulk stores that Graham won't. So it'll be interesting when we start to unload some of these later stores, quite what it's like. Bulk stores we've unloaded to date, we're not seeing any scorch at the base or anywhere. So but it is a big learning curve, and we'll just have to see how things go.
Yeah, I think as
Am I allowed to say anything, Laura?
Yeah, no, of course, please.
I was going to say it isn't just about the air movement, of course. The fogging process itself can also give rise to a relatively wet fog, which would be more inclined to deposit. So that's also a factor, maybe from one year to another. So we had this with CIPC, so we want a nice dry well, with CIPC we wanted a dry fog, but we want something where the chemical isn't hurried into the store.
So that's quite interesting, isn't it? I think overall what I'm hearing is that, you know, obviously we've got to be aware that the ethylene and mint oil are different to CIPC. So knowing those being aware of those chemical properties and going into your store on a regular basis and observing, seeing what works, what doesn't, and improve from there to find, you know, the best possible solution for a particular scenario. So I think if we moved on, we've had several questions come in on temperature. And again, I think if we could go back to you, Graham, and Colin, at what temperature do you keep your potatoes, whether that's, you know, with ethylene and mint oil as well? That'd be some useful information, and how you go about managing that. You know, obviously depending on the varieties that you store. Colin, if we could start with you.
Yeah, so the temperature regimes are sort of quite straightforward for us. You know, the longer term varieties that we've got for our crisping customers, we're around about the 7.5 to 8 degrees. They still show good sugar profiles on, from the fortnightly sampling we do, and good fry characteristics at those temperatures. Earlier and mid-term varieties, we do tend to run a little bit higher, so we would be 9.5, and then possibly even the most earliest about loading, the pre-Christmas stuff. We may not take that down much below 11. We'll have a nice slow pull down depending on how warm the harvest is. So if we don't need to pull the temperature out, then we won't. We'll just nice steady pull down and then straight into factory.
Okay, what about you, Graham? For your
just focusing on the fresh side, it's fairly straightforward. It, you know, often 2.7 to 3 degrees in a fresh store will be what we'll be running at. One thing I will say, it's Adrian mentioned, could we go temperature alone? But some of those stores that are such an age, if you try to go too much lower, your blowing hours would be almost 24/7. So if you put, even what I find down at some of those, when you're on the limit of design as such, an age, that going from a 2.8 to a 2.5 set can make a massive difference. So, but as a general range, 2.7 to 3 would be cover most of it.
Okay, yeah, that's interesting, because that goes into the engineering side of things, and Adrian, I think you mentioned, you know, will we be moving towards more refrigeration as well, and that obviously has some implications in terms of energy costs as well.
And capacities. Graham's right. I mean, different fridges have different capacities, and the older fridges, as they age, then the efficiencies tend to drop off, and particularly if they were probably running on older refrigerants that have now been replaced with more modern refrigerants that are less efficient, basically, because they've got better environmental characteristics, but not necessarily better refrigeration characteristics.
So I'm aware we're getting closer to finish time, so I think we'll finish probably with one last question, or looking around carbon dioxide levels. And it's been quite interesting to hear from all of you, whether that's from a research perspective or what you've been observing on the ground. And I think an interesting question to finish off there is, you know, how far do we push it in terms of, you know, keeping those carbon dioxide levels high, and how far do we push the store closures? You know, obviously there is the risk, and there's a certain level that we can't really go beyond, but how can we strike that balance? I guess probably a question for you, Adrian Cunnington-Bridden, and then we'll move on to Graham and Colin.
Sorry, Laura, do you want to repeat the question then, please? Because I was just trying to scan some questions there, and I've missed what you just said. Apologies for that.
It's just a finishing comment on carbon dioxide levels and how far do we push that and store closures, because I think, you know.
Okay, well, I think Adrian's shown quite a lot of data there. That, I mean, some of your numbers were going up to about 20,000 ppm, Adrian, I think. So yep. That's 2%. I would say that's the sort of limit we need to be. We don't want to be going much above that for the health and safety purposes. That's only at 15,000 parts per million. You're only allowed in the store for 15 minutes. So we get into some really difficult areas if we start getting CO2 levels getting up past those sort of levels, just from a safety perspective. Once you're into that area, into a controlled spaces regulations and things like that, which we don't really want to be having to deal with on your average farm. So, you know, locking the stores and all that sort of thing to prevent any accidental access and things like that. So I think it is important that we have a do have a discussion on where we feel that people should draw the line, because at the moment I think most people's CO2 management will keep it well below that, but I wouldn't want people to think that they can just go away and allow CO2 escalate significantly above, well, certainly not above 10,000 parts per million, I wouldn't think, or 1%.
AB, did you want to add any comments?
Yes, I think we'll get into a situation, if we allow CO2 levels to go up too high, we'll get into a situation where we actually have to ensure that we lock stores to prevent access. But my guess is that CO2 levels won't go as high in commercial stores as they do in our stores here at Sutton Bridge. So we're in relatively small CA type stores within another building. So they're relatively protected, relatively sheltered. It'd be interesting to know what kind of concentrations of carbon dioxide we see in those commercial stores that are looking at the 72-hour closure period. That's perhaps the first thing we should do.
So another call to arms there for our audience to share any data and experiences. I think, you know, the more we can learn as an industry, the as a whole, the better. Graham and Colin, any final words on carbon dioxide?
I'd just like to comment, if you're monitoring your CO2s, you'll know your stores, and you'll know the ones you have to be worried about and the ones you don't have to be worried about, but probably worried about in a different manner. So if you're talking just purely in that mint-or lockup period, I have stores that maybe have an old air mix system where the louvers are not sealing well at the back, etc., and running the fans flat out for 3 days, actually that they're self-ventilating, which means they're actually probably losing the product you're putting into there. So I think CO2 build up during that period is probably a good indication of, in some ways, how much of the products you're actually keeping in the store. On the newer builds, prior to this and hearing about CO2, some of them will build very rapidly and hit 8,500 within 24, 36 hours. And in some cases there, I gave them a very minor flush. But as time's gone on and more CO2 work is coming available, you feel a bit more confident you can keep shut up for a longer period. But I would say, if you're monitoring CO2, you'll know your stores, you know which ones are an issue, but issues in different ways, i.e. why isn't that CO2 building up in a full store while it's shut up, for example?
Thanks, Graham. Colin, any last words?
Yeah, Graham's dead right there. Figures that we're seeing, I think, from the commercial stores that we've done, I should think on average we're getting sort of about 5,000 ppm as a peak. It does oscillate up and down, and as Graham alluded to, I think we are seeing a little bit of leakage coming into some of these big warehouse type buildings. I think the highest peak I've seen was somewhere around 8,000, and that was on a 72-hour shutdown. So at those figures, we'd seem to be getting, you know, okay control. and no detrimental effect on fries at those. So that's good, and it's interesting to what Adrian said earlier about the effect with ethylene on CO2. So yeah, it was interesting there.
Thanks, Colin. Well, I think we've had some more questions come through, but we'll follow those up directly with you. But in the meantime, I think we'll probably draw to a close. So I think if we can have the next slide up, Christian. Just a reminder of the resources that we do have available. So the Potato Storage Hub is the online portal where you can find all the latest information, resources, latest research reports from the storage trials that we discussed today. You can stay up to date with announcements and research trials as well by signing up to our storage bulletin. Adrian mentioned the storage advice line, as well as the storage network, which hopefully nearer the time with restrictions easing up, storage network partners will be able to go out to you and visit your stores and provide that crucial advice. And of course, as well, we've got storage webinars that you can watch back, including this one. Next slide. And then finally, before you go, we really value your feedback. So if you could take a couple of minutes to fill in the survey that you should be directed to after the end of this webinar. And if you've got any questions, then do let me know, and I'll be more than happy to help and put you in the right direction. And we've got a final, we've got an upcoming webinar as well next week, not on storage, but looking at Rhizoctonia, so you can sign up on our webpage. But on behalf of all of our delegates, I'd like to thank all of our speakers. Thank you very much for joining us today, and to you in the audience, thank you as well for joining, and we hope to see you at one of our next events. Thank you very much, and have a good afternoon.